Hi guys, it's me again, Julie Sundar, and today's part 2 of building the IoT stack for Cosmos IT Core HackOmation 2018. In our previous tutorial, we went along and did the basic installation for a few microcontrollers such as the Raspberry Pi 3 and the Lincoln Smart 7688 Duo. But before we continue for the developing of the IoT devices, we'll be following the HackOmation stack. The HackOmation Quadrant consists of 5 layers: the UI layer, hardware layer, communication layer, control layer, and encapsulating all of these layers is a networking layer. The UI layer is basically your graphical user interface or your dashboard that you'll be using to interface to your IoT device. Your hardware layer is when developing an IoT device, you'll be controlling basic GPIO pins or controlling actuators or reading from basic sensors. For your communication layer is how are you going to communicate between your IoT devices or to your IoT device. We'll be giving examples of socket communication, REST API, or MQTT messaging protocol. And for your control layer is where the smartness happens. For my first example, I'll be showing you guys how to use Nodejs as an orchestrator to distribute tasks. So for this tutorial, I'll be showing you guys how to develop a simple end-to-end IoT solution based on the HackOmation Quadrant. All aspects of the quadrant will be apparent to more or less detail. So for the program for today, we'll set up Nodejs as our orchestrator. We'll be creating our dashboard, using WebSockets as our communication, and controlling our hardware by controlling GPIO pins to our blinker LED on and off. So let's begin. I recommend that you guys watch my previous tutorial of the basic installation of the Raspberry Pi 3 with Nodejs, that you have Nodejs and npm installed. And for hardware, we'll be using Raspberry Pi 3. You'll be needing a breakout cable and a breadboard, 4 LEDs, and some resistors. So we're going to start off by connecting to PuTTY and checking if Node.js and npm was installed. We're going to go ahead and open PuTTY and connect to a Raspberry Pi. I'm going to type in the IP address and log in here. Once logged in, to check the version of Node.js, you can simply type in the terminal node -v. And to check the version of npm, you can do npm -v. And as you can see here, Node.js and npm is already installed. So let's go ahead and go over the sample code for this project. So next, what you want to do, since we're going to be going over files, we're going to log into WinSCP, which makes it much easier to read and write files to and from your Raspberry Pi. Let's go ahead and log into WinSCP with our IP address. Once connected, I presume that you guys already have Node.js and npm installed, therefore the folder structures also. Let's go ahead and navigate into a Node.js folder. And in our project folder is where our app is. It's called Quadrant 1. In Quadrant 1, we have our Node modules folder, which will contain all of our libraries. Public folder, which contains our client app and our app.js. In our public folder, we have our CSS folder, which contains our app.css. Our JS folder, which contains our JS libraries, which is jQuery and Socket.io. And our index.html. So let's go ahead and go over the code in our app.js. For your first part, which is here, we went ahead and created our Express server. Then we went ahead and linked it up to our HTTP server. And then we linked our socket server to our just created server. And we selected our port to listen on port 3000. But you can check whatever port you prefer. Next, we're going to go up and set our routes to our client app, which is in our server. So you're going to tell it to use a static path pointing to my public folder. In the public folder is where the client app is actually stored. Now once the sockets are set up, meaning the socket is on, you will start handling the messages coming over and on the socket server. In this case, you can get a message open command or close command. As soon as the open command comes in, it will first start by re-emitting, sending it over the socket for all other connected users so they know open command has been issued. And this part is where the action actually happens. Here's where you act on the open command. You will emit the open valve command to that listener that responds to that, and it will do as appropriate. And here is the opposite. So let's go ahead and check the index.html file. This is actually the client page. It consists of 3 parts. The first part has all the libraries and styling. We currently have app.css, which has all the stylings for a button, and socket.io client library, and jQuery library. And here, there's a portion of script which will be taking care of the socket stuff. And at the bottom, we have the physical stuff like the buttons and the gauges that will either control or respond to the scripts. So let's go ahead and start with the script. The script in itself is pretty simple. On starting of the page, it creates a socket connection to the server. This address should match your server address, which is currently the IP address of my Raspberry Pi and on what port the server is listening on. As you see on the server side, we have the open command, open valve, close command, close valve to respond to. When some users on the network issue a command to open it, the server also emits a message to the other users that the open command has been issued. So you will respond to it and you will change the circle from red to green. And in the event of the valve actually opening, it will remove also the inner circle from red to green and opposite for closing. You receive the close command, it will turn the circle into red, and once the valve actually closes, the status will also change. So finally, there's the listeners and the button clicks of the users on the client page itself. Once somebody clicks on the open button, it will emit the open command over the socket, and the same for the close. It will just emit close command over the socket and everybody will respond accordingly. So let's go ahead and scroll down to our body where we have our physical buttons. If you guys would like to connect to specific GPIO pin of your Raspberry Pi, you can change the ID here. I'm currently connecting to pin 17, 25, 24, and 13. So that was it for this part. Let's go ahead and run our app. So let's go ahead and log in back into PuTTY and connect to a Raspberry Pi IP address. Then you want to go ahead and navigate to where your project is, which is in Nodejs projects Quadrant 1, and run our app by typing node app.js. And as you can see here, your app is running and it's served up on port 3000. And as you can see here, if I connect to my Raspberry Pi on port 3000, I get the dashboard with my controls. And I can turn my pins on and off. I just turned pin 17, 25, 24, and 13 on, and then turn them off. Congratulations, that was the end for this tutorial. Stay tuned for the next tutorial. So hey guys, that was the end for this tutorial. We just went over building a simple end-to-end solution using the HackOmation Quadrant. For our next tutorial, we'll be covering a little bit more advanced topic. We'll be looking at the communication layer and developing our own REST API. The REST API is basically going to do the same thing as we did in this tutorial today, but it's essential for when you're going to move on to mobile app development. So stay tuned for our next tutorial.